today we're going to just do a hands-on workshop-based presentation. So everything is in Jupyter Notebook. What I'm going to do is during this presentation, I have 3 notebooks. So before I go into each notebook, I'm going to share the link to you so you can actually follow along during the class, during this webinar, or you can do it in your own pace later on. All right, so we're going to get started. We have about 95 people join us, which is what I expected, about pretty much half the number of people who signed up. So we're going to get started. My name is Bibas Bhattacharya, and there's my email address. If you have any question after the presentation, you can definitely ask me. And I've been working with machine learning for about 3 years now, a little bit more than 3 years, and won a couple of projects. And I live in Miami, so we have a lot of cruise companies here. And most of my projects have been with cruise companies. And so we're going to get started. And one thing I would like you to do is, if you have any question during the presentation, please ask me. Don't wait for the end of the presentation. We do have about 10 minutes allocated for Q&A at the end, but you don't have to wait for that. Please go ahead and ask me a question anytime, and I'll be happy to answer. So first thing I'm going to do is I'm going to share my, I'm going to share the first notebook. And I'll post it in the chat section. So the link is going out in the chat, and you should have it. And I think I just gave you a read-only access. I just want to make sure you don't go ahead and change the, yeah, you should not be able to change the code. If you do want to change the code later on, just make a private copy of it and it'll be fine. Okay. So today's presentation is about, introduction to TensorFlow. So we're going to keep it fairly basic, not get into too much details. And if time permits later on, we might get into more low-level aspects of TensorFlow. All right. So what is TensorFlow? TensorFlow is a machine learning library from Google. And it's the most popular library right now when it comes to machine learning. And there are some good reasons behind it, and I'll get into some of those. And when it comes to computation, we have now another library called Pytorch, and that's from Facebook. And they're very similar in okay, I made a mistake. I did not post the link to all attendees. Okay, my bad. I'm going to post the notebook link to all attendees now. You should get it now, my fault. Cool. So yeah, the nearest computation is Pytorch from Facebook. They're very similar in nature, except Pytorch is a little bit younger. It's a little bit newer, has fewer following, less mature, but they have very similar architecture and scope and goal. So 2 main things about TensorFlow is that it supports GPU-based computing, and it supports NVIDIA GPU. Not any other kind of GPU from AMD and stuff like that. So primarily it supports NVIDIA GPU. And it also supports distributed training. Distributed means you can train a model involving multiple machines. So you can, let's say you have 10 or 15 machines, you can put them in a cluster, and you can run your training in parallel in multiple machines. So when it comes to some complicated real life projects like I don't know, maybe oil and gas industry runs a lot of complicated models. If you're doing weather prediction, things like that, where the model needs a lot of data, millions and millions of samples of data, you need fairly powerful machines to run your training because you want the training to be done as soon as possible so you can evaluate it and make sure your model is good. If not, you have to go back to the drawing board, change your model, run training again. So TensorFlow definitely is going to help you. It's going to help you speed up the training process. So one of the questions was, can Python use this library? Yes, for sure. Python is the main programming language for TensorFlow. and all the code you're going to develop today are Python based. A lot of the time what happens is that, the training part would use Python, but when it comes to inference, where inference means you're actually doing prediction. For example, you are pointing the camera at an object and you're trying to figure out what that object is. That's called inference. And whether it's going to rain or not, that's an inference or prediction. That aspect needs to be pretty fast, and that can run on your cell phone, could be running on the web. And when it comes to this inference phase, you could develop the solution using any number of programming languages. You can use C++, for example. You could use, if it's an iOS application, you could, TensorFlow has a Swift language-based library. Similarly, there is library in Java. When it comes to inference piece, there are many different programming languages supported by TensorFlow. At the very low level, TensorFlow is developed using C++ and C, so something to keep in mind. So you can always get down to that level of detail and then write your code. But most of the time, when it comes to running the training, we do this in Python. All right, so that's, I hope, was sufficient for, okay, so people are having problem with the notebook error. I'm not sure why. We'll get to that a little bit later. Let's just follow it on the screen for now. All right, so we're gonna get down to some of the basics about TensorFlow. So one thing you gotta keep in mind, TensorFlow does something called graph-based computing, which is a little bit different in the way we do computing in Java or in regular Python. So let's say we want to add two numbers, 10 and 20. In Java or Python, you'll simply do a 10 plus 20 and you're going to get the result 30. We don't do that in TensorFlow. We have to build a graph first. So in this case, for example, the graph has an operation called add, and there are two operands which are scalar numbers, 10 and 20. So this is how the graph is built. And once you build the graph, you can then execute the graph. Okay, you can execute the graph any number of times. If you execute it once, you're going to get the result back, which is 30. And you can keep on executing it. Okay? So that's called graph-based computing. So first, take a look at an example of it, and then I'll explain to you why we do a graph-based computing. Why do you have to go about in an indirect way to do computation? What are the benefits of that? By the way, Pytorch from Facebook does the same thing. So there is a good reason behind why we do graph-based computing, and I'll get to that. First, take a look at a couple of examples. Okay, in this example, we're going to build a very simple solution to the problem of adding two numbers, like we see up there. We're going to add two numbers. So to add two numbers, we have to first declare two placeholders. So you see the two placeholders I'm declaring. What is a placeholder? Placeholder is a way to supply input values to a model. So in this case, we are going to be supplying the values of A and B. We know what the A and B are. We are going to be supplying those values. And when we supply value as input, we have to create placeholders for them. So here we are creating two placeholders, and we are saying that the data type is a floating point. And optionally, you can give it a name. Giving placeholders names is going to help us later debugging, and I'll show you what I mean by that. So the names are optional, but it's generally recommended you give them names, some kind of a friendly name. Okay, so now we have two placeholders, and all you have to do now is create the operation. So you do add operation, tf.add, and we are saying add two numbers, and out comes an operation. So this is not the result. So we're not going to get the value 30 here because we haven't even told what the values of A and B are at this point. So all we have done is built a graph so far that looks kind of like this diagram up there. All right, so let's keep executing this. First, I need to import TensorFlow. And this, then let's go ahead and just build the graph. So now we have the operation created. Now that we have the graph built, we can execute it. And we can execute it any number of times. So to execute a graph, we have to create a session, a TensorFlow session. So we create a session using the constructor tf.session. And so we have a session now. And then using session.run, we can execute the operation we have created earlier. And if the operation takes any input values, we have to supply that using the feed dictionary. And you can see that we are saying that the value of A is 10 and value of B is 20. So the placeholders are the keys to the dictionary, and the value to the dictionary are the actual values of the placeholders. So we are supplying a dictionary to the run method call here. Okay, and when you then execute the operation, what you get back is the actual addition operation result. So let's run this one. So let me run this, and we expect the printout to say result is 30. Okay, so as you can see, the result is 30 at this point. So this is a very simple example of doing a graph-based computing. Any questions so far how this we created the graph and how we executed that? Okay, so since there is no question, we're going to now talk about the virtues of graph-based computing. Why do you do this? So once you build a graph, it's very easy for us to assign the work to any number of GPUs you may have on your machine. You don't have to learn anything about GPU-based computing, which is super complicated. Because GPU computing is all about parallel computing. You've got thousands and thousands of cores in GPU. You have to manage all that. You have to talk about assigning memory, copying data to the GPU cores, and it's a super complicated process. And you don't have to do any of that. Essentially, we are wrapping over the GPU computing API using graph-based computing. And if you have a GPU, and when you are defining the session, you can say use a GPU. And then TensorFlow is going to assign the computation graph to that GPU. Okay. And it's the same way distributed computation works. So if you have a cluster of TensorFlow machines, TensorFlow session can then assign the computation to a particular machine in the cluster. And it can also do parallel computing. If the graph allows for parallel computing, it's going to then go ahead and parallelize the work. And it can also do some optimization of the computation, which I don't want to get into at this point, but the first 2 points are easy to understand. You can easily do GPU computing. You can also distribute the workload in between multiple machines. And all of this is possible because we are doing graph-based computation. It makes life super easy. All right, so now we built a simple graph, and this is how the graph should look like. But now we're going to actually go and visualize this. How do we visualize things in TensorFlow? Is using a tool called Tensorboard. All right, there's a tool that comes with TensorFlow called Tensorboard, and we can do all kinds of debugging and monitoring using this tool. So what you're going to do now is that we're going to create another session, and we're going to create a file writer, and we're going to ask it to save the whole graph of the current session into the file system in the log folder. Okay. So basically, we are dumping the whole graph into the file system, and then we are closing the writer. After we do that, we're going to launch the Tensorboard tool, which is a web-based tool. So let's see how this looks like. All right, so the Tensorboard now is fully integrated with a notebook. So the Tensorboard board website open right within the notebook tool. So you can see that the graph here, it opens the graph, and you can see that exactly what you expected. We have the add operation. So operation is add, and then you got 2 placeholders, A and B, okay? So this is one of the reasons we always give names to placeholders and variables, so you can actually observe it in Tensorboard, and it makes sense when you look at it, all right? So that's Tensorboard. Next, we're going to create a variable, and variables are used when we save the result of some kind of a computation in a storage space. So think of variables like a storage space, and you can store any kind of value there. So typically when we run a model and we are learning things, like we are learning weights and biases, and we save the learned values of the weights and biases in variables. So this contrasts that with the placeholders, where we supply the value. These are known values that we supply in the placeholder as input to the model. And think of variable as almost like output. So when you compute something, the result can be saved in a variable. All right, so here we have a problem that we're solving here, which is we create a variable called I. We give it a name called myvar, and we are adding the number 1. We are adding 1 to that variable. So the variable is initialized with 0 first, and we are adding 1 to it. All right. And then we are taking the result and we are assigning the result to I again. So essentially what we are doing is we're incrementing the value of I. So we are adding the number 1, and then we are assigning the result to the variable I. We're updating I. So as we keep running this graph, the value of I is going to be going up by 1 every time. All right, so let's run this guy. So we have the operation now. So we create a session, and this time we have to initialize all the variables. Even though we have said the initial value is 0, we still have to initialize variables. And then what we do is we go in a for loop. We we do this 5 times. We run the operation 5 times. So this operation that we created earlier, we run this five times. And remember, every time you run the operation, the value of I is going to be incremented by 1. So then we get the current value of the variable. To get the value of any variable, we have to basically call session.run and just give it the variable. So in our case, the variable is I, and out comes the current value of I. And then we simply print out the value of I at this point. So if we run this, you're going to see that the value of I is going to go up by 1 every time. So you can see that step 0, our value of I is now 1, then 2, 3, 4, and 5. So here we learned how variables work. We also learned how to execute an operation multiple times, okay? So we built the graph and we are running it multiple times. Okay. So now we're going to learn a little bit about matrix operation, because in machine learning, we do a lot of matrix computation. So yeah, go ahead, Vincent, you have a question? All right, so question was, can you explain the global variable initializer? Okay, so a little bit too much details here. So interesting thing is that we said here the value of I is initialized with 0, right? But this is all graphs. You're not actually doing any assignment here. You're not actually saying create I with 0 as initial value. This is not, Python or Java programming. So if you look at the graph here, you'll see that there is an initialization node that is attached to the variable I. Okay, so that assignment of 0 to I happens when you run this guy here. When you call this, then all the variables get initialized with their initial value. So this is why we have to do this. Let me see if I can go back and show you the current graph. Maybe that'll make sense. You see that my variable has an initialization node. It's also a node that is attached to the variable. So when I call initialize global variable, that this graph gets executed, and that's when I becomes 0 at that point. And all these assign and everything is in this piece. You can see also the init value is attached to the my variable node here. So it's all we are just building graph, and when you call the initialize global variable, that's when the initialization happens. All right. let's go. We're running behind schedule at this point. So let's go ahead and create two matrices. First one, so matrices have dimensions. So it's the same as placeholder, same as before, but now we are saying it's a 4x2 matrix, and that's X, and Y is a 2x5 matrix. And then we are multiplying two matrices, and that becomes the operation. And since we are multiplying a 4x2 matrix with a 2x5 matrix, you know that the result is going to be a 4x5 matrix. Okay, that's the expected value, expected result. So let's go ahead and do this. Let me run this guy. And then same as before, now we have, we are supplying values to X and Y. And same as before, we run the operation, we supply value using feed dict, X and Y. All right, pretty straightforward. Let me run this guy. And out comes the result of the matrix multiplication. So that tells you at a very low level what goes on in TensorFlow. We build a graph, then we execute the graph. All right. All right, so let's keep moving because it's already 12:25. I will move to the next notebook. Let me go ahead and share the link also. So this is the second notebook. Oh, all of this requires that you have a Google, you're logged in as Google, okay? Log into your Google account and then you should be able to access these notebooks. So by the way, do you know what tool I'm using here to run these notebooks? Do you know what tool it is? If you know, just type it into the chat section. So I'm not running Jupyter in my local laptop. I'm actually running this on a cloud. Do you know what this cloud tool is? Yeah, very good, thank you. So we are using Google Colab. So collaborative laboratory, Google Colab, which is an awesome tool. Some of the benefit, one of the main benefits is that, first of all, everything is saved in my Google Drive. So I don't have to worry about that. I could be anywhere. I could have a very low-end laptop, could be a Chromebook and whatnot. It could be maybe even a large phone. I could use that. And I could run my computation in Google Cloud. Another cool thing is that you can go to Edit, Notebook Settings, and you can see that you have access to GPU. So Google gives you fairly high-end GPUs. I mean, each of these GPUs are probably $6,000 or $7,000. You don't have to have this in your local laptop or machine, and you can just choose to use a GPU and use it. So it's extremely useful. It's hard to even explain how cool this is. But I'm not using GPU for these labs because I don't need it. The calculations are fairly straightforward. All right. So now that we know about TensorFlow, a couple of things we need to talk about. Working with TensorFlow at a low level like that with sessions and placeholders and variables can become fairly complicated after a while. We do recommend that you learn about it. If you are going to be if you're a senior architect or a machine learning engineer and you're leading a team of developers, you need to know about the low level stuff. And in our training, for example, we do get into this low level TensorFlow quite a bit. Whether it's a regression problem or you're building a neural network or you're doing image analysis, image recognition, we teach you how to do everything using low level TensorFlow. But there is also this high level API that comes with TensorFlow. All right, so there are a couple of choices when it comes to high-level API. What the high-level API does is that it makes life easier for you. You can start writing code fairly fast. So let me write this down here. So a couple of choices for high-level API are Keras. And then the TF estimators. All right, they both make most common tasks fairly straightforward. Keras Keras is packaged with TensorFlow now. So when you install TensorFlow, you get Keras with it. You don't have to install it separately. TensorFlow is free, Colab is free. So question is it free? Yes, Colab is free and TensorFlow is free. Everything is free. And you get the GPU for free as well. One thing to keep in mind is that these runtimes or the virtual machine is destroyed after 12 hours. And no problem with that. You just open the notebook again and you get a new virtual machine. The downside is that the files, if you have any files, they'll get deleted. So you have to re-upload the files and then go from there. So the virtual machines are alive for 12 hours, which is pretty good. All right, so now we're going to learn about how to code using Keras, which is a high-level API, and it makes life super easy for us. So the problem here is we have a very cool problem we're going to solve. It's a toy problem. We're going to do a weather prediction. We're going to predict whether it's going to rain or not. It's a Boolean result, yes or no, whether it's going to rain or not based on temperature and humidity. So we know that when the temperature is high and the humidity is high, there is a high chance of rain. And on the other hand, when it's cold and it's dry, probably it's not going to rain, okay? And so, so when you look at that, we show you some of the training data. So in the first few cases, we have, so each one is, each training sample is the temperature in Fahrenheit and then the humidity in percentage, okay? So we have about 1, 2, 3, 4, 5 training data samples that it's going to rain because it's hot and humid. Then we have 1, 2, 3, 4, 5 more training samples where it's cold and dry. You can see the temperature is low and it's dry, humidity is low, and it's not going to rain, okay? So these are our features. Each feature, each training sample has 2 features, temperature and humidity. And then is the labels, and the labels are predicting, is telling us whether it's going to rain or not. 1 means it's going to rain, 0 means it's not going to rain, all right? So this is our training data. We're going to train a system. We're going to train a neural network. And then we're going to use the neural network to predict whether it's going to rain or not. We're going to feed it some unseen values of temperature and humidity, and it's going to predict. All right, any questions so far about the training data? So it's a toy examples. In our course, we use simple examples like this so that you can focus on the concepts, not get bogged down by cleaning up data, preparing data, which in itself is a lot of work. So when we first introduce a new API or new concept like a neural network, we always give you a very simple problem to solve. And then you go into cleaning up data and data processing part, which is a huge aspect of machine learning. It comes later. So here we have a very simple problem. We're going to predict whether it's going to rain or not. And first, we're going to build a neural network. So in a neural network, as you can see, the input layer, we need a node for every feature. We have 2 features here, temperature and humidity. So you have 2 nodes in the input layer. In the first hidden layer, we're going to have 25 neurons. So 1, 2, 3, up to 25 neurons. And the activation function for the first hidden layer is going to be ReLU, or rectified linear unit. And we'll learn about that. And the second hidden layer has 10 neurons. And again, the activation function is going to be ReLU, or the rectified linear unit. And we are doing classification here. So and it's a binary classification, whether it's yes or no answer. That means the output layer has only 1 neuron. And for the output layer, we are going to use an activation function called Sigmoid. We're going to learn about this very quickly also. So if you are interested in the low-level stuff, you can see that the number of weights, because every neuron gets an input from the previous layer. So in the hidden layer, neuron number 1 gets 2 inputs. And for each input, it needs a weight. So that means each neuron needs 2 weights. We have 25 neurons, so 25 times 2. So we got 50 weights in the first layer. Similarly, 10 times 25 weights in the second layer. And for the output layer, we need 10 weights because there are 10 neurons in the previous layer. So just to do some computation, keep you, if you know about neural network, just to do a cross check. All right, so knowing this architecture, let's go ahead and build this. In Keras, we build a sequential model, and then we are saying that the first layer is 25 neurons, activation function is ReLU, and the input dimension is 2. That's because we have 2 features in the input. And then we add a second hidden layer, where we have 10 neurons there, and again, activation function is ReLU. And finally, we have the output layer, and we are doing binary classification, so we need only 1 neuron, and the activation function is sigmoid. And then we go ahead and use this optimizer called Adam optimizer. There are several optimization approaches, algorithms available from TensorFlow, but Adam is pretty popular. We're going to use that. All right. And then we are compiling the model. We're basically building the model. So let's quickly go through the activation functions. ReLU means if the output from a neuron, so let's pick the neuron number 1 here in the hidden layer. If the output from the neuron is less than 0, then we're going to completely suppress the output. In other words, the output is going to become 0. We're not going to output anything. It's like a gate. If it's less than 0, we don't output it. If it's more than 0, then it's a very simple linear value. Y becomes y equals x. It's like a y is same as x. So whatever is the actual computed output gets output. If it's less than 0, we don't output. This is super important. This suppression of output is extremely important for a neural network. This is how we get non-linearity. We can model any function, whether it's a sine function or a circle or a parabola. Any kind of function can be simulated using a neural network because of the suppression. Now, this, by the way, also happens in biological neuron in our brain. A lot of the time, the neurons don't fire. They receive signal, but they don't fire. They just suppress it. So this is one of the similarities with the biological neuron as well. And in the final output layer, we use sigmoid. So in a sigmoid, what happens is that it doesn't matter whatever output, whatever input comes in. It could be any number. If you use sigmoid, the number is going to be transferred between 0 to 1. You can see that here in this graph. So whatever the x is, the y is going to be clamped between 0 to 1. So it could be x could be 1,000, could be negative 1,000, it doesn't matter. The output is going to become 0 or 1, which is super important if you're doing binary classification. All right, so which is the case here. We're using predicting whether it's going to rain or not. So we're going to use a sigmoid activation function in the final layer. So all you have to do is supply sigmoid here as the activation function. All right, now that our model is built, let me actually go ahead and run these guys. I did not run them. So let me run that. Let's run this piece. Let's go ahead and build the model. And we're going to run the training. So to do the training, all you have to do is model.fit and supply the training samples, the features, and then the labels. All right. And how many times you're going to go through them and to run the training. We're going to go through the entire training data set about 100 times and continue the training. So let's run this guy. So you can see that it's going to run it, and we are achieving almost 100% accuracy at this point with the training data, which is good. So now the model is totally trained. All the weights and biases that we have are all there now. Let me delete this one. Now we can go ahead and evaluate the model. To evaluate the model, we're going to give it some unseen data of new values for heat and temperature and humidity that we did not use for training. So these are new data samples. And again, for the first 2, we expect to rain. And for the second 2, we don't expect to rain. So then we evaluate the model with the test features and test labels. So these are new unseen data. And if we run it, you can see that the accuracy is again 100%, which is awesome. That's because we trained using a set of data. Now we are doing evaluation using a new set of data, and we are still getting 100% accuracy, which is very good. Why do you have 25 on layer 1? Question is, why do you have 25 on layer 1? As you know, these values are called hyperparameters. You need to play with these. There is no definite rules. You need to see what a combination of these numbers give you the best results. And I played with it, and these numbers are giving me good results, so we're going with it. Okay, there's no hard and fast rules for this. Okay, lots of questions regarding the same. Again, it's all hyperparameter, you have to play with it. This is why it's super important to run your training quickly. Question is there any reason to use ReLU and Sigmoid? I hope I answered the question. How do you decide on the parameters like epoch? The epoch is, you got to keep training and see if the accuracy is improving. If I run it for only 50 epochs, I did that, and you'll see that the accuracy is about 80%. So I kept on increasing it until I got about 100%. So keep on increasing the number of epochs until the accuracy stabilizes, okay? Beyond that, there is no point training any further. You're just wasting time. All right. So now during validation, I'm getting 100% accuracy, which is awesome. Now let's do prediction. So prediction is what happens. This is called the inference phase. And this could be happening like, you know, let's say you are speaking into Amazon Alexa or Google Speaker, all is doing inference at this point. It's not doing any more training. When it comes to speech to text, the training that can take days. And it's already trained by Google. You know, the speaker is not running any training. The smart speaker is doing only inference. Same thing when you're doing any kind of AI using your cell phone, is running on an inference. You know, it's not doing any more training. So these inference phases at this point, we are basically giving it the test features. These test features are these guys, these temperature and humidity function values. And we are going to get some predicted value out of it. So we call model.predict, give it a feature, and you're going to get the prediction back. And all you have to do now, remember the predicted value is the sigmoid value, and it's going to be pretty close to, most cases it's going to be close to 1 and 0. It's not going to be exactly 1 and 0. We have to do rounding. So if it's more than 0.5, we're going to assume there is 1, which means it's going to rain. If it's less than 0.5, we're going to have to round it to 0, meaning it's not going to rain. So that's why during prediction, I'm doing rounding here. I'm rounding the predicted value. All right, so let's run this guy, and you can see that the truth was 1 and the predicted value is 1 and so forth. So we're getting 100% accuracy here. Any question? All right, very good. So what we did in this notebook is that we use the high-level API from Keras. Okay, question here. When I train, I get different results for accuracy first. Yeah. So when you are training, the accuracy should increase gradually. That's totally normal. And it should, in a best case scenario, the accuracy is going to increase and it's going to stabilize. And that's when we got to stop training. There's no point training any further. It's very common. That's what learning is all about. System is learning and it's getting better and better. Same for, by the way, the process is the same for all AI models, whether it's a speech to text, text to speech, you know, all of that, product recommendation. You're going to do training, and during training, the accuracy is going to keep on increasing. It's going to get better and better. If you see during training, the accuracy is going down, that's a very bad sign. Something is very wrong with the model or your data. All right, I don't have time to get into all that, but if you are not seeing accuracy improving and stabilizing during training, something is wrong. That need to be rectified. And we teach all of that in our courses. Just don't have the time here for that. Okay. Let's go. We got about 15 minutes left. What we're going to do now is we're going to take a look at a problem. And this time we're not going to use Keras. We are going to question is, as a sigmoid goes from 0 to 1, but again, we are assuming that 0.5 is, yeah. So question is, do we have to round around 0.5? Question is, it's totally up to you. If you want even stronger confidence level, you can round it above 0.6, for example. So you can say if the value is more than 0.6, then we're going to round it to 1. Okay, then we know it's going to rain. If it's less than 0.6, we're going to think that it's not going to rain. It's totally up to you, but it's more, in most cases, 0.5 is considered to be the threshold. I hope that answers your question. Let me see if I can clear all these questions. I don't know Zoom enough to clear all the questions. They're going to be sitting there. Okay. Question is, in this example, we didn't use placeholder. I am wondering in what kind of model we would use placeholders. Yeah, that's because we're using the high-level API. Behind the scene, Keras is creating placeholders and variables and so on and so forth, okay? It's totally hidden from us. And that's a good question because that will introduce our third notebook. In the third notebook, we're not going to use Keras. We're going to do everything using low-level TensorFlow. So bear with me. It's going to be a little bit more complicated, not as simple as TensorFlow. But hopefully it'll make sense. So question from Samrat is, how do you know how much to train? I hope I touched on that. Your accuracy should stabilize. If you look at my results when I did the training, let me run the training again. So let's run the training for only 50 epochs and let's see what happens. You'll see that, well, in this case, it did quickly converge, but in some cases, you'll see that the accuracy is, because this is a toy problem, it learned very quickly. Well, you know what? That's because it's already learned. The state is preserved. I need to restart the runtime. That is the problem. I need to restart the runtime. Let me go ahead and so basically I restarted the virtual machine. And then let me run these guys again. And then run the training for 50 epochs, okay? So you can see now the accuracy started with 0.5, 0.5, 0.6 is going up, and it did go up to 1. So after 36 epochs, it already reached 1. So there's no point training after that. So I can totally bring down the number of epochs to, let's say, 40, and it'll still be good. So I could theoretically bring it down to 40 at this point. I don't need to train any more than that. Okay, so those are the general guidelines. If I run it again, it's going to start with 1 because it already has learned the weights. So you're going to see the accuracy is already going to be 1. You need to go and restart the runtime if you're using Google Colab to do the whole thing again. All right, I hope that answers your question. So keep on training until you stabilize the accuracy. All right, now we're going to take a look at things. We're running out of time here. Let me share the notebook. All right. So we're going to do things in low-level TensorFlow. So let's look at the problem statement. So you know that the Fahrenheit and Celsius are related in a linear fashion. So we know how to convert from Fahrenheit to Celsius and vice versa, but machine doesn't know that. But we're going to teach the machine how to do the conversion, all right? We're going to give it a couple of samples of conversion, and it's going to learn from it. And we're going to do this using low-level TensorFlow. So we know that the relationship is linear. So we're going to model this using a linear function where y, or the prediction, which is in Celsius, is equals a weight times x. X is the Fahrenheit value plus a bias of b. So x is known at all times. X is the given value in Fahrenheit. We're going to learn w, or the weight. We're going to learn the bias b. These are the two things we're going to learn, okay? So going back to placeholders, um, um, X is always given as input, so it's going to be a placeholder. W and B are learned, so they're going to be variables, all right? So let's build a model. So first we declare variables, W and B. Then we're giving it, because there's only one feature, which is the Fahrenheit. There's only one feature as input. So those are the dimensions of W and B. And we create a bunch of placeholders. X, which is in, X is in Fahrenheit as an input. So that's a placeholder as well. Y is the label, which is a placeholder. During training, we supply the label values in Celsius. And again, there's only one feature and one output, Celsius and Fahrenheit, only one value. None means indeterminate number of samples. You could feed it as many training samples as you want. We don't have to hard code the value here. So we set it to none. That means it could be any number of sample data coming in. And when it comes to prediction, we simply do a matrix multiplication, X times W, and we add B to it, and that gives me the converted value. So once again, we are converting from Fahrenheit to Celsius, okay? So the Y is going to be Celsius value, and X is the Fahrenheit value. So that's our model. And then we compute the loss or the inaccuracy in our prediction. So inaccuracy is the Y hat minus Y. And because it could have be a negative value, we square it up to get rid of the sign. And then we take an average across all the data samples. All right, so it's called a root mean square loss function. It's very popular. The core is right here. The inaccuracy is the difference. It's simple as that. And because it might have a negative sign in it, we square it up. We do a TF square, and then we do an average. Okay, that's our inaccuracy. And we are trying to optimize this loss. Again, we are using Adam optimizer. We are asking it to optimize that loss. And this is the learning rate. I don't have time to explain what a learning rate is, but it will take me about 15 minutes. It's not super complicated. Okay, so that is our model right here. And we are returning all the placeholders and variables and the model and everything from this function. All right, let me run this guy to get the function done. And then we're going to do training, okay? We build a model, and we get the model, we get the placeholders and variables, all right? And then we have some training data, we are feeding it. So these are some straightforward Fahrenheit values here and the corresponding Celsius values, okay? We're going to give it some training samples here. We create a session, and we create a saver, and I'll explain to you what the saver is for. But these are familiar initialization of the variables, and we're going to train it for about 40,000 times. Okay, so we have 40,000 epochs in this case. We're going to go through the entire data sample 40,000 times, and we are basically running training right here. This is the most important step. We are running the model, which is the model is basically the optimizer. And we are giving it the X and Y values, training X and training Y. X is Fahrenheit, Y is Celsius. And it's basically going to run. And every once in a while, what we do is we print out. Every 2,000 epochs, we save the current weights and biases in the file system. This is what the saver is for. We save the current weights and biases, and then we are computing the loss value just to print it out. These are for debugging only. So this entire section here is optional. This is for debugging only, all right? Just to show us how the training is progressing, whether it's stabilizing or not. And then if we get the error rate less than 0.001, we don't need to keep training anymore. So we are dynamically here breaking out of the training, and you can do that in real life also. So once you achieve a certain accuracy level, just get out of it. You don't need to train anymore. All right, so let's run this guy. So so this is the train function. Let me bring this into the memory, and then simply run training at this point. So you can see that the loss is steadily going down. That means the accuracy is improving. So this is a classic example of a good training process. And it has reached a certain level, and we are ending the training right there. So we are printing out the weights and biases. So at the very end, you can see that the weight was 0.555 and the bias was -17. Do these numbers look familiar to you? Where did these numbers come from? So let's take a look. We know that these Celsius to Fahrenheit conversion, it follows this formula, C over 5 equals F minus 32 over 9. If you rearrange this equation, you'll come up with this. C equals 0.55F minus 17.778. So you see that exactly it has learned those values from our data sample. Isn't that cool? And that's what machine learning is all about. So basically, we have a scientific formula. We don't need to know anything about this scientific formula. The machine can learn just by looking at observed samples. And we are seeing that in actual science also, a lot of the cases, they're not bothering to figure out what the formula is. They're just letting loose a machine learning model, and it figures it out. So it's a new way of doing science. It's very cool. All right. Then it comes to prediction. So to run the prediction, I need to restart the runtime. And let's do this again. I need to build a model again. I don't need the training function. I can go straight into predict function. So in the predict function, what I'm doing is that I create a saver and I load the weights and biases that I had saved during training. So I'm going to load it up. And then I have some unseen Celsius and Fahrenheit values. I'm going to run prediction and give it the unseen Fahrenheit values, and it's going to give me the Celsius values. And I'm going to print it out, okay? And I know what the expected values are going to be, because in this toy simple problem, I know what the expected values are. I'm going to print it out as well, just to see how good the prediction is. All right, let's run this guy. So again, this is the inference phase. This could be happening on a cell phone, smart speaker, website. TensorFlow has a JavaScript library also, so you can run the inference on web-based applications using Angular or whatever it is you are developing the front end with. So you can run the prediction phase in the web page as well. So let's run this guy, run the prediction. And you can see that the predictions are minus 39.99, and we expected 40. Prediction was 36.66, and this is the expected value was, and so on and so forth. They're very close. So that shows that our model is working. So that's the end of this presentation. We have about 5 minutes left. Please ask me a question. I hope this was useful. So what we did is we looked at how graph-based computation works using some very simple examples. We looked at high-level API using Keras. We did weather prediction. And then we created a model using very low-level TensorFlow. And we taught it to do conversion between Fahrenheit and Celsius. I'll be here for another 5 minutes, and feel free to ask any question. Excellent, guys. Very good questions coming from you guys. Very happy to answer those questions, and hope to see you again. By the way, we are developing tons of courses on this. We do have a 2-day-long workshop-based course for TensorFlow. Again, all our courses are now becoming more workshop-based, very few slides and stuff like that. Everything is you learn through very carefully designed workshops. So the workshops are going to be starting with a toy problem like this. Then we give you very real-life problem, getting real-life data. So you're getting data from hospitals, from Airbnb, and many different sources. And you're going to be solving medical problems. You're going to be solving other business problems. And when you are confronted with real-life problems, trust me, you're going to face so many issues. You have to navigate around those issues. And we teach you how to do all that in our courses. So the RNN is something we don't cover in our 2-day course. In our 2-day course, we go regression, we go logistic regression or classification, and then we end with image recognition. And that ends with the 2-day course. And then subsequently, we go into RNN, recursive neural network, LSTM, we go into GANs, generative adversarial network. And we go into some of the common business problems like product recommendation and your recognizing sentiment analysis from text. Question, how do you know which model to use? Don't you need to know the relationship between your predicted and unpredicted variable first? All right, so what we did here in the Celsius and Fahrenheit problem, we know that the relationship is linear. So we went for a linear regression here. So if you know machine learning, what we basically did here is a linear regression. So linear regression is something you can think of. It's like a neural network with only one neuron in it. It's kind of like that. You can think of it like that. So it's a super simple neural network with only one neuron. That's what we just did. And I wanted to keep the example simple. I didn't want to build a full neural network. But if you think that the relationship is non-linear, then you have to use a neural network, because neural network can model any relationship, any. It's a universal solution that can model any relationship. Could be exponential, could be complicated, non-linear relationship. It will figure it out. Your model may have many hidden layers, many neurons, but it will figure it out. So, if you are not sure, it's a brand new problem domain, you have no idea what the relationship is, go with neural network. The only drawback of neural network, which is the follow-up question, is that neural networks feed on data. You need to supply a lot of data to it during training. And of course, the training can take time. So we use linear regression if we know that the problem is simple. Then we want to train quickly with fewer amounts of data. Also, our inference is going to run faster in a low-end hardware. That's something to keep in mind. How much horsepower do you need to run the inference? So considering all of that, we decide on a model. But if you're not sure, go for a neural network. Yeah, you do need, question is, I don't have Google account. Can I have the document by email? You do need Google account. Otherwise, you won't be able to run these. You won't be able to run the notebooks. All right, more questions. Lots of questions. Okay, I did, where do we get the materials? I did share the link in the chat for all 3 notebooks. That's the way to get a hold of this material. Thank you, Anjali. Thank you for the compliment. Can you share the first 2 notebooks again? Okay, let me go ahead and share the notebooks again. Copy the link. So notebook. Notebook number 2. And notebook number 3. All right, all 3 notebooks are there. You just have to log in as Google. Now, if you're logged into Gmail or something like that, you're already logged in, and then you should be able to run these notebooks. Now, to make changes, you may have to make a private copy of it, because I did not give you write access. Okay. Thank you, and hope to see you in a class. I don't have any Gmail list, Mike. I'm just saying that if you log into Gmail, you are logged into Google, and you should be able to run these notebooks. You just have to be logged into Google, that's all. Okay, more questions coming in. Thank you. Would the recording be shared? I'm not sure. See, I don't do this very frequently. We are recording this. If you have a WebEdge contact, can you please email the WebEdge contact? Or just email me, send me an email, see what I can do. I have let me put my email in my chat. That's my email. Please shoot me an email if you need to get a hold of the recording. I'll put you in touch with the right people. It's going to take a few days. What is the IP1B extension? That's the Python notebook. Anything else you suggest to acquire more knowledge? You have to come to our classes. If it is recorded and recording, okay, will be available to registered attendees. I guess, okay, so we are going to send you an email with the link to the recording. We are recording this, so you should have it in a few days. It takes a while because the size of the recording. I think we run webinars almost on a weekly basis. Let me see if it's in our website. In our website, free webinars. So our webinars are listed here. I'm going to paste the link. We run very cool webinars every week, and they're all listed here. You can also look at the recordings of the past webinars. So they're all listed here. All right, guys, thank you so much for coming and asking me all these excellent questions. I hope it was useful, and see you again.